Welcome to 3.5 Part 3, Elimination. In example number 1, we're going to solve this system of equation using the technique called elimination. So here's our system of equations, or our two lines, and we're going to go over to the whiteboard and work this out.
Example number 1, we're given two equations. X plus y is equal to 8, and x minus y is equal to negative 2. Now, if you notice that by adding up these two equations, if I add up x plus x, I get 2x, but y minus y cancels out, and then if I add 8 minus 2, I get 6. So I'll divide by 2, I'll divide by 2, and I'll get 3. So if you notice that by adding these two equations up, because they're the same with opposite signs, I'm able to eliminate the y and solve for the x. So now I've solved for one of the variables. So now I know that x is equal to 3. And I can use this, and I can label these equations 1 and equations 2, and I can use this knowledge to find out what y is. Because remember, we're talking about a coordinate x, y, where they intersect. And that means where these two equations have that coordinate in common. So now I'm going to take, let's say, equation number 1, and I'm going to plug in the x is equal to 3. So I get 3 plus y is equal to 8, then minus 3, and that means that y is equal to 5. So y is equal to 5, and the coordinate is 3, 5. Now, of course, what I want to do now is I want to make sure that I found the right ones, because if it is a coordinate that both of these equations have in common, that will mean if I plug in this into x and this one into y, then I should get that answer, because they both have this coordinate, or should have this coordinate in common. So I'll check both equations. So I'll check x, well, that's 3 plus 5, question mark, is equal to 8. Well, we know 3 plus 5 is equal to 8, so that means that's correct. Now I'll take x is equal to 3, minus 5 is equal to question mark, negative 2. Well, it turns out that 3 minus 5 is indeed negative 2, so that means that's correct. So therefore, that is the coordinate that both of these equations have in common, or where they intersect, or where their lines intersect at that point.
In reviewing what we did on the whiteboard, since the y coefficients are already the same with opposite sign, adding the equations together would result in the y term being eliminated. And so we end up with 2x is equal to 6 after we add up these two equations. The result is one equation with one variable. And we solve for x, and we find that x is equal to 3. Once one variable is eliminated, the process to find the other variable is exactly the same as the substitution method. So we take one of the original equations, let's say x plus y is equal to 8, and we'll substitute in x is equal to 3. So there we get 3 plus y is equal to 8, and now we can solve for y, and we get y is equal to 5. The solution is 3, 5. This is the point where the two lines intersect. Now, of course, you want to check to make sure that your solution is correct. So we check it with the one that you didn't use in this particular problem. So in this case, we already used x plus y is equal to 8, so we'll do the check against x minus y is equal to negative 2. So I will substitute in 3 where I see x and 5 where I see y, so I get 3 minus 5 is equal to negative 2. And I see that 3 minus 5 indeed is equal to negative 2, and that means that my solution is correct. In example number 2, we're asked to solve, using the technique of elimination, this system of equations. So let's go over to the whiteboard and work this out.
In example number 2, we have 5x minus 2y is equal to negative 15. And we have 3x plus 8y is equal to 37. Now, in this case, if you notice, we cannot just add them up. None of the variables will cancel out. If we add up the x's, they won't cancel out. If we add up the y's, they won't cancel out, because the idea of elimination is to eliminate one of the variables by adding something up. And then we can just solve like a regular algebraic equation, at least one of the variables. So what we're going to do instead is we're going to multiply one of these equations by something to allow one of the variables to drop out. And in this case, I'll take the top equation and I'll multiply it by 4, and I'll do nothing to the second equation. So if I take the top equation and I multiply it by 4, I get 20x minus 8y is equal to negative 60. And the bottom equation, I'll keep that the same. So that's 3x plus 8y is equal to 37. So I'll add, now I can add them up, and if you notice, the y's will cancel out, and then I'm left with 23x is equal to negative 23. And then I divide by 23, and then I find x is equal to negative 1. So now I have one of the coordinates. Now the next thing I need to do is choose one of these equations and solve for y, because I need a coordinate, and a coordinate consists of an x and a y, where the two lines intersect. So I will take, let's say equation number 2, and I'll plug in negative 1 where there's the x, because I just solved for that, plus 8y is equal to 37. So now I have negative 3 plus 8y is equal to 37. Or plus 3, and that means I get 8y is equal to 40, divide by 8, and that means y will be 5. So now I find that my coordinate is negative 1, 5. Now, in order to check it, I should probably check it against both equations, but if I don't have time, I check it against the equation that I didn't use to find the other variable. So in this case, I will use equation number 1 because I used equation number 2 to find y. So I'll plug in 5 times negative 1 minus 2 times 5 is equal to question mark negative 15. And so 5 times negative 1, well, that's negative 5. And then negative 2 times 5 is negative 10. And that's equal to negative 15. And indeed, negative 15 is equal to negative 15. So I'm good to go.
Reviewing what we did on the whiteboard, since neither variable will drop out if the equations are added together, therefore we must multiply one or both of the equations by a constant to make one of the variables have the same number with opposite signs. The best choice is to multiply the top equation by 4, since only one equation would have to be multiplied. Also, the signs on the y term are already opposite. So we do that, and there we see we get negative 8y, positive 8y, and when we add that up, they cancel out, so we end up with 23x is equal to negative 23, and that means x is equal to negative 1. Once one variable is eliminated, the process to find the other variable is exactly the same as the substitution method. So I chose the first equation, 5x minus 2y is equal to negative 15, and I substituted in the x that I found previously, that was negative 1, and I substituted in the x right here. And I found, after I worked it out, that y would be equal to negative 5. And therefore, the solution is negative 1, 5. And this would be the point where the two lines intersect. Now, of course, I want to check against the one that I didn't use. And since I didn't use the second equation, I will use that one. So I will substitute in my x is equal to negative 1 and my y is equal to 5 and see if it works out. And I keep on going, and I get 37 is equal to 37, and that is true, so everything is okay. In example number 3, I'm asked to solve the system of equations using elimination. So why don't I go to the whiteboard and work this one out?
As an example number 3, you have to multiply both equations by something in order to get one of the variables to drop out. So in this case, we have 4x plus 3y is equal to 8. And then we have 3x minus 5y is equal to negative 23. So if we look at these two, we see that we can't just multiply the top by something or the bottom by something in order to make one of the variables drop out. So we have to figure out a way that it can drop out, so we have to find a way in which we can multiply the top and the bottom by something in order to get it to drop out. So what I'm going to do, I'm going to multiply the top one by 5 in order to get positive 15 in the y, and I'm going to multiply the bottom one by 3 in order to get negative 15, and that means I'm going to have the y drop out. So let's see if this is how it works out. So 5 times, so I'm going to multiply it through, and I'm going to get 20x plus 15y is equal to 40. And then the next one, which I multiply by 3, I'll get 9x minus 15y is equal to negative 69. So now I can add these two up. So when I add these two equations up, it turns out, as I mentioned, the 15, positive 15 will cancel out with negative 15, and then I am left with 29x is equal to negative 29, and then I divide both sides by 29. So in this case, I get x is equal to negative 1. So I found one of the coordinates. Now, as before, I'll choose one of these equations. I'll label them 1 and 2. And I'll choose one of these equations to plug my newly found x in and use it to find my y. So I'll just use, in this case, 2. So I have 3x minus 5y is equal to negative 23. Well, x is equal to negative 1, so it's 3 minus 1 minus 5 is equal to negative 23. So far, so good. So now I have negative 3 minus 5y is equal to negative 23, plus 3, and minus 5y is equal to negative 20. Divide by minus 5 on both sides. And I find that my y now, my y coordinate is 4. So it ends up, I get negative 1, positive 4, and this would be the coordinate where my two lines intersect. And if you run out of time, it's always best to check it against both equations, but I'll check it against the one that I didn't use. So I've already used 2 to find y. Let's see if I get the correct answer when I use 1 as a check. So I'll take 1, and I have 4x I found to be negative 1, plus 3, and y. What did I find y to be? I found y to be 4. And question mark, is that equal to 8? Well, I have negative 4 plus 12 question mark equals 8. And negative 4 plus 12 indeed is equal to 8. And indeed, I'm good to go.
Reviewing what we just did on the whiteboard, for this system we must multiply both equations by different constants in order to make one of the variables drop out. It would work to multiply the top by negative 3 and the bottom equation by 4, or to multiply the top equation by 5 and the bottom by 3. So I'm going to multiply the top by 5 and the bottom by 3. And I get the top. Remember, when I multiply by 5, I have to multiply through by everything. And similarly, for the bottom one with 3, I have to multiply through by 3 by everything. Now I can eliminate the positive 15y and the negative 15y, and I'm just left with everything in terms of x. So I find that x is equal to negative 1. To find the second variable, it will work to substitute in any equation that contains the two variables. So in this case, I will use the equation 4x minus 3y is equal to 8. I found previously that x is equal to negative 1, so I substituted in the x as negative 1, and then I solved for y in order to get y is equal to 4. Thus, the solution is negative 1, 4. Now, of course, I want to check this against the equation that I didn't use. And I didn't use the equation 3x minus 5y is equal to negative 23. So I'll substitute in the negative 1 for x and the 4 for y and solve it. And indeed, I get negative 23 is equal to negative 23. In example number 4, I'm asked to solve this system of equations. So let me go over to the whiteboard and work this out.
Now let's see what happens in example number 4. And here we have two equations. We have 3x minus 2y is equal to 4. And then the other equation is negative 6x plus 4y is equal to 7. So we just have to multiply one of these equations to have the number drop out, to have the variable drop out. And we can drop out the variable y by multiplying the top equation by 2. And the bottom equation we'll leave alone. So we'll end up with 6x minus 4y is equal to 8, and then negative 6x plus 4y is equal to 7. Now it turns out everything cancels. The x cancels out, the y cancels out, and we end up with 0 is equal to 15. But that's not true. 0 is not equal to 15. This is bad. No. So what does it mean when you have something that doesn't really make sense? Well, that means it's an inconsistent. It's inconsistent, or we can say there's no solution. No solution, because this doesn't make any sense because 0 is not equal to 15.
Reviewing what I just did on the whiteboard, we eliminate x by multiplying the first equation by 2 and adding the result to the second equation. So here we have it, and we find that 0 is equal to 15. Now this is not true. 0 is not equal to 15. Unlike the other checks where we got the number is equal to the number, and that means it's true. But this is not true. So therefore, we found that it's an inconsistent system, meaning that there is no solution. We also call the solution set the null set. This means there is no solution. In example number 5, we're asked to solve this system of equations. So let us go over to the whiteboard and work this one out.
Now let's see what happens in example number 5. So here we have two equations, negative 4x plus y is equal to 2, and we have 8x minus 2y is equal to negative 4. So let's multiply the top equation by 2 so that we can eliminate one of the variables. And we end up with negative 8x plus 2y is equal to 4. And then we'll keep the bottom one the same. 8x minus 2y is equal to negative 4. And it turns out we get 0 on both sides. But this is true. 0 is equal to 0, and this is true. So that means if you get a situation where you get that it's true and the equality is true, like in the case 0 is equal to 0 or 4 is equal to 5 or whatever is equal to whatever, that they're the same whatever, that means that there are infinite number of solutions.
Let us review what we just did on the whiteboard. We eliminate x by multiplying the first equation by 2 and add the results to the second. So here we have it, and we get 0 is equal to 0. Well, this is true. Each equation is a solution of the other. That means that there are infinite many solutions. A word about elimination. Elimination is sometimes referred to as linear combination. Elimination works well for systems of equations with 2 or 3 variables. The goal of elimination is to manipulate the equation so that one of the variables drops out or is eliminated when the two equations are added together. Now let's look at a few extra examples and figure out how we want to work these out. And we can use any method we like. So here I'm going to look at this particular set of equations, and it looks like I will use elimination for this one. So what I'm going to do is I keep the first equation the same, and the second equation I'm just going to move things around a little bit so that I end up with negative 2x plus 3y is equal to negative 13. This means now I can eliminate the x's, so I end up with 0 plus 4y is equal to 12. So now I can solve for y, and I get for y positive 3. I substitute in y is equal to 3 in one of the original equations. In this case, I'll use the first equation, and I find that x is equal to 11. So my answer is 11, 3. 11 for the x, 3 for the y. Notice how I put my x first and my y second because this is a coordinate. Then I check against the equation that I didn't use, and the equation that I didn't use was the second one. So wherever I saw y, I put 3, and wherever I saw x, I put 11, and I found 9 is equal to 9, and that means everything is fine. In example number 7, I'm asked to solve this particular set of equations, and in this case I can use any method I want, but the method I will use here is substitution. So I substitute in wherever I see x, I substitute in negative 2y minus 4. So here is the 2y minus 4 plus 4y is equal to negative 18. And then I continue and I solve this like a regular algebraic equation until I get y is equal to negative 3. I substitute in negative 3 in one of the original equations, and in this case I will substitute it into the second equation to get x. So I substitute in negative 3 where I see y, and I solve and find x is equal to 2. So my coordinate, or my ordered pair, or my point is 2, negative 3. And then I check it against the equation I didn't use, and in this case the equation I didn't use is the first one, so I put wherever I see x, I will put 2, and wherever I see y, I will put negative 3, and then I solve and I find negative 18 is negative 18, and indeed this is true, so we are good to go. In example number 8, again I solve by any method, and in this case I will use elimination. So here I will multiply the top equation by 3 and the bottom equation by 2, and this allows me to eliminate the x's because I end up with a negative 6x on top and a positive 6x on the bottom. But remember, I must multiply through the 3 by the whole equation and the 2 by the whole equation. I can't just multiply it by the things I like or want to multiply it by. So I end up with y is equal to negative 7. I substituted y is equal to negative 7 into one of the original equations. So in this case, I used the first equation. So I substituted negative 7 wherever I see y, and then I solve for x, and I find that x is equal to negative 3. So now I can write the coordinate negative 3, negative 7. And then I check against the equation I didn't use, which was the second equation, and I found that the x is equal to negative 3, the y is equal to negative 7, and then I solve this, and I find indeed it's true, negative 23 is equal to negative 23, so therefore my answer is correct. Thank you very much. I hope that you enjoyed this video. Take care, be well, and goodbye for now.